It might sound like something straight out of a science fiction film, but this actually happened. A few years ago, an incredibly strange object entered our solar system, leaving scientists completely baffled. It was named Oumuamua. This mysterious visitor had an unusually bizarre composition, lacked the typical glowing tail seen in comets, and moved in a way that couldn't be explained by gravity alone. This led to a question that captured imaginations worldwide: what exactly is Oumuamua? Was it simply a rare natural phenomenon from deep space, or could it be evidence of an alien spacecraft sent by an advanced civilization? Surprisingly, this theory wasn't just internet speculation, it was seriously proposed by a respected Harvard professor. Now, after years of debate, astronomers believe they may have finally solved the mystery of this interstellar enigma. So stick around, because by the end, you'll discover the latest insights into what really entered our solar system back in 2017, a moment that marked a major milestone in modern space exploration. It was on this day that Robert Weryk, using the Pan-STARRS telescope in Hawaii, detected an object within our solar system that was unmistakably interstellar in origin. At first, the discovery sparked excitement, but that excitement quickly gave way to confusion. This unusual visitor had characteristics so strange that scientists couldn't determine exactly what it was. The object was named Oumuamua, a Hawaiian word meaning scout or messenger. Initially, experts believed it to be a comet. However, that assumption didn't last long. Follow-up observations found no sign of a tail or coma, features typically associated with comets. Within just a week, astronomers made a dramatic shift and reclassified Oumuamua as an asteroid. But anyone who thought the mystery was solved was in for a surprise. The object's flight behavior defied all known patterns associated with asteroids. To put things into context, when Oumuamua was first spotted in October 2017, it was already heading back into interstellar space. Calculations revealed it had passed its closest point to the Sun, its perihelion, on September 9. Although the object came as close as 37.6 million kilometers to our Sun, what it did next left astronomers baffled. Trajectory analysis revealed an unexpected twist: the object accelerated in a way that couldn't be explained by gravity alone. In simpler terms, as Oumuamua moved away from the Sun, it picked up speed slightly beyond what gravity should have allowed. This puzzling behavior immediately drew the attention of experts. At first, scientists considered the possibility of outgassing, the release of volatile substances, as a potential cause. This theory wasn't far-fetched, since it's a common phenomenon when a celestial body is heated intensely. In such cases, evaporating ice can release gas, producing a kind of thrust that causes additional acceleration. However, this approach came with a major limitation. Typically, outgassing causes noticeable changes in an object's rotation, yet no such changes were observed in Oumuamua. This only deepened the mystery surrounding the object. To uncover its true origin, scientists directed nearly every available telescope toward it. What they found was that Oumuamua exhibited unusual and dramatic fluctuations in brightness, suggesting that its shape might resemble a giant cigar. Yet, the data wasn't sufficient to link these brightness changes to any specific rotational pattern. This led to the theory that Oumuamua isn't spinning on a single axis, but instead is tumbling chaotically through space. Even more puzzling was the complete lack of dust around the object. Initially, experts believed the object contained no water and might even be composed entirely of metal. However, determining its exact size proved difficult due to limited data. Scientists had to rely on estimates, which varied depending on assumptions about its reflectivity, density, internal strength, and rotation axis. Based on these variables, Oumuamua could be as small as 100 meters or as large as 800 meters in length. Its origin was equally uncertain. The only likely clue is that it came from the direction of the Lyra constellation. Although it was first classified as an asteroid, it was later reclassified as a comet, or at least that's one possibility. Some studies suggest it could be a frozen hydrogen object, while others propose it might be a nitrogen ice fragment ejected from a Pluto-like planet. But what if none of these natural explanations are accurate? What if Oumuamua isn't a naturally occurring object at all, but rather an artificial structure deliberately sent into our solar system for exploration? That brings us back to the provocative theory proposed by Harvard professor Avi Loeb, that Oumuamua could be the work of an extraterrestrial civilization. To grasp Avi Loeb's perspective on extraterrestrial life, it's helpful to first consider his background. Born on February 26, 1962, in Bethlehem, Israel, Loeb is a prominent yet often controversial astrophysicist. He has made bold claims, one being the discovery of unusual objects on the floor of the Pacific Ocean, which he believes could represent extraterrestrial technology. According to Loeb, these include hundreds of small spherical fragments that he says originated from a meteorite and may be of interstellar origin. You might also recall the supposed alien mummies revealed in Mexico's parliament in September 2023. Interestingly, during that presentation, it was none other than Harvard professor Avi Loeb who joined the session remotely to discuss his ongoing investigations into extraterrestrial artifacts in Earth's atmosphere and the solar system. With this context, Loeb's controversial theory about the interstellar object Oumuamua becomes less surprising. He suggests it could be the creation of an advanced alien civilization. Its unusual acceleration and the absence of dust trails align with what one would expect from a highly reflective, ultra-thin object with a broad surface, exactly the kind of signature an artificial craft might exhibit. In this context, Loeb proposed a bold theory, that Oumuamua might be an alien solar sail, a craft powered by radiation pressure from the Sun or another star. Surprisingly, this hypothesis wasn't entirely dismissed by the scientific community. In fact, the mysterious object was closely examined using the radio telescope at the Green Bank Observatory in West Virginia, nicknamed Mountain Mama, in an effort to detect any potential artificial signals. However, after 2 weeks of observation, the results were disappointing. No signs of artificial origin were found. Does this mean the mystery of Oumuamua has been resolved? Since its discovery in 2017, few cosmic objects have puzzled scientists more. But in March 2023, a breakthrough finally emerged. A team of astronomers announced they had unraveled the mystery of Oumuamua and explained the cause of its strange acceleration. So, have all the mysteries surrounding Oumuamua finally been solved? Let's break it down. One thing is clear. No scientist has ever observed a comet quite like this, one without a dust coma and displaying such unusual acceleration. That is, until researchers Daryl Seligman and Jennifer Bergner proposed a compelling new theory to explain it all. Their idea centers around hydrogen propulsion as the driving force behind Oumuamua's strange behavior. The scientists based their conclusion on a series of lab experiments from the 1970s to the 1990s, which showed that water ice exposed to intense cosmic radiation can break down into molecular hydrogen. An object moving through the interstellar medium, like Oumuamua, would be bombarded by such radiation, essentially cooking it over time. This leads to a logical assumption: Oumuamua could have generated hydrogen during its journey. However, there's a catch. The mysterious speed increase it exhibited near the Sun would only make sense if that hydrogen didn't escape immediately into space. Luckily, the researchers had an answer. They suggested that the hydrogen stayed trapped within tiny pores in the ice. Their calculations showed that, under interstellar conditions, much of the hydrogen produced in this way would remain locked within the water ice. It would only be released when the object's temperature rose, specifically between -258 degrees Celsius and -33 degrees Celsius, allowing the built-up hydrogen to escape and propel the object forward. As long as this threshold isn't surpassed, the water ice remains in an amorphous state, meaning it only transforms into a crystalline structure when heated to the right temperature.